In number 4, the 4 many denominators all go into 7m. So I'm going to multiply both the numerator and denominator by 7m and do some canceling in each of these corners. In the top left, the 7's cancel, leaving m squared. In the top right, the m's cancel, so I have minus 49, 7 times 7. In the denominator, the 7's cancel, leaving me m times 1, m. And the m's will cancel, leaving me with plus 7. Now we note the difference of two squares there in the numerator, which is m plus 7 times m minus 7 over this m plus 7, and you can see it. We're going to have some cancellations here, and our final solution or simplification here is going to be m minus 7.
And I want to find the least common denominator of the p, 2, 3, and p, which is 6p. And I'm going to multiply through by 6p over 6p because that is equal to 1. And since I'm multiplying through by that fraction, I can distribute this 6p to each of these mini fractions along the way. Now, let's look at this one corner at a time, so to speak. In the top left corner, the p's cancel, leaving 6 times 2, which is 12. In the top right corner, the 2 will cancel with a 6, leaving 3 times p times another p, so I have plus 3p squared. In the bottom left corner, 3 will cancel with a 6, leaving 2 times p distributed multiplied by the other p makes 2p squared. And in the bottom right corner, the p's will cancel, leaving 6 times 3, which is minus 18. Now I'm going to rearrange this and do some factoring and cleanup and see what we can do with this. I'm going to rearrange this to become 3p squared plus 12 over this denominator 2p squared. And actually I'm going to factor the 2 out, make it 2 times p squared minus 9. In the top left corner now I can factor out a 3, have p squared plus 4 left over, and in the denominator we have 2 times p plus 3 times p minus 3 because the p squared minus 9 is the difference of two squares. Now we'd like to be able to factor the sum of two squares in the numerator, but it's not factorable, and we're not going to have any cancellation anyways. So this would be our answer in factored form. We could actually leave our answer in the first form we had it up there because nothing's going to factor and cancel. It's kind of your choice on how you leave your answer. But the one I've circled here is usually the main one we write because we like to show by having a factored form that there will be no reducing possible.
On number 6, I'm going to treat these whole numbers as being over 1. Look at the 1k, 1, and k as the least common denominators of those many denominators, and basically multiply through by k over k. What we're going to have now is 6k plus 6, because the k's will cancel there, and we will have k plus 1 down in the denominator. Now all we need to do is factor a 6 out of the numerator, leaving us with k plus 1, which will then cancel with the k plus 1 down in the denominator, and this quotient will be 6. In this next expression, let's look at the denominators. This 1 is over 1, the 2 over there is over 1. It looks like we want to multiply through by x squared over x squared and simplify the fraction that way. Up in the numerator, there's nothing to cancel with here, so we just have 1 times x squared, which is x squared. In the center, that x will cancel, so we have x times 1, so plus x, and then the x squareds cancel and we have minus 12. Doing the same thing down in the denominator, we will have 9 minus 3x minus 2x squared. Now it's probably time to try to factor the numerator and denominator. The numerator will factor into x plus 4 times x minus 3, and I don't want to rearrange this with a negative 2 in front, so I'll just factor this as it is, 3 minus 2x times 3 plus x. And nothing is going to cancel after we factor it, so we really have two choices on how we write this quotient. On number 8, I look at the many denominators. I notice that their least common multiple is b times b plus 1. So that is what I'm going to multiply both the numerator and the denominator by. In the top left corner, I have a 5. After the b's cancel, it will be 5 times b plus 1. I then have a plus 4 in the top right, and after the b plus 1's cancel, it will be multiplied by a b. Then in the denominator, same thing. The b's will cancel, so I will have 4 times b plus 1 minus 5 times b. Do not cancel these b plus 1's. They are not factors of both the numerator and the denominator and not free to be canceled with. Let's do some distribution. We have 5b plus 5 plus 4b over 4b plus 4 minus 5b. Combining like terms, in the numerator we have 9b plus 5, and in the denominator we have negative b plus 4, which can also be written as 4 minus b if you choose.